Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to explain about projectile motion. So anyone who has tossed any kind of object into the air has observed a projectile motion, as shown in figure on the left side of the screen. Projectile motion is a two-dimensional motion which consists of x component and y component. In this case, the positive x direction is horizontal and to the right, while the y direction is vertical and positive upwards. The most important thing about projectile motion is that the x component and y component are independent of each other. This means that the motion in one direction has no effect on the motion on the other directions. So we can solve the problem. We need to treat x and y component separately. Let's consider three variables in projectile motions. Number one, forces. Is there any forces acted on the object in x component and y component? Number two, acceleration. Is there any acceleration on x and y component? And three, velocity. Is the velocity constant or changing? For the forces, since we ignore any air resistance in our syllabus, so there is no forces acted in x component. Therefore, the object will move with constant velocity. Since there is no forces, so the acceleration is also zero. Sum of F is equal to ma. The net forces is equal to zero. Hence, the acceleration must be also equals to zero. If the acceleration is zero, therefore the velocity is constant. However, in y component, the object moves under the influence of gravity. So there is a gravitational force downward. If there is a gravitational force downward, there will be an acceleration which is equal to negative g, and g is given 9.81 meter per second square. Since the object moves with accelerations, therefore the velocity of the object is changing. To solve problems related to projectile motions, we can use equation developed in subtopic 2.2. The three equations are v is equals to u plus at, v square is equals to u square plus 2as, and s is equals to ut plus half at square. But the important difference between subtopic 2.2 and projectile motion is that the initial velocity is now, in fact, all velocity has two components, which is x and y component, as shown in this figure. Now, can you correctly resolve the initial velocity into x and y component? And can you give the expression of angle theta? If you use trigonometric functions, The x component of this velocity is given by u cos theta, and the y component for this velocity is given by u sine theta. Angle theta can be calculated by using the inverse tangent of uy divided by ux. On the other hand, all the equations in subtopic 2.2 can be written into two separate components, x component and y component, which is simply Vx is equals to ux plus axt, v square x is equals to u square x plus 2ax sx, and sx is equals to uxt plus half axt square. For y component is vy is equals to uy plus ayt, vy square is equals to uy square plus 2ay sy, and sy is equals to uyt plus half ayt square. However, we can simplify the equation because we already know that acceleration in x component is 0, while the acceleration in y component is negative g. Can you simplify the equation by yourself? For the x component, we end up with Vx is equals to ux, and Sx is equals to ux times t, because acceleration is 0. For the y component, we have Vy is equals to uy minus gt, Vy square is equals to uy square minus 2gs, and Sy is equals to uy t minus half gt square. Let's check whether if you simplify the equation correctly. That's all for this video. In the next video, we are going to use this equation to solve problems related to projectile motion. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.